Everybody see that? Good. Okay, dissertation power hour. Da, 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 da. We're going to define our variables. So I know they put you guys through a lot of statistics, heavy duty, advanced statistics, not the easy stuff, the graduate level statistics. And I know that can be quite hairy, to put it nicely, for a lot of you guys, including me. It took me about 5 years to learn this stuff where they expect you guys to learn it in 2 semesters. But, you know, knock on wood, I got to hire a lot of the TAs, so they taught me. But we're going to teach you how to, you know, identify a variable and define it. So these are for quantitative dissertations, not for qualitative. Quantitative, and quantitative basically means it's got numbers in it. You're going to collect numbers, you're going to collect data, you're going to run a bunch of inferential statistics on them. All right. So first of all, what's a variable? I deal with a couple of students and they're not sure what a variable is per se. So remember, the root word of variable is to vary. And that is anything that changes from person to person. So they have to deal with measurements about subjects. Subjects are people who are in the study, right? Like their annual income, their test scores, what type of therapy they're going to, anything like that. Anything that can be measured with a number, or where a number can be used to define a rank or a level, that kind of thing. So in other words, a measurement that changes in value from subject to subject is a variable. And that's you know, that's such a wide range of information that that's why you got to get real specific. All right, so measurements. Now we're going to talk about the types of variables. So there's basically 4 types of variables, and we're only going to talk about 3 of them because one of them I don't like. So, and I'll go over that in a second here. But so, you know, here's a type. Here's several different variables. Age, person age changes. Their gender changes from subject to subject, and then you got your Likert scales. You guys familiar with Likert scales? That's your good, great. 1, I hate it. 5, I love it. That kind of stuff. So age, because it's a number scale, think of it as a number line. That makes it a continuous variable. Continuous comes from calculus. You don't need to know that. But it also goes by scale, score, ratio. It has many different names, but they all basically means the same thing. It's a number that's on a number line. The hint between that is a continuous variable can have fractions. It can have decimals, right? A person could be 27 and a half years old. So because it has fractions and decimals, that makes it continuous. Okay, SPSS calls it scale or something, but we'll go over that again here in a second. Right, yeah, SPSS calls them scale variables. Same thing, like it's like you got a ruler where it's got inches and it's got, you know, half inches and, sorry, you guys are getting robocalled to death here. And then gender is a nominal variable. A nominal variable, I would rather use the word categorical because it makes more sense to me. A categorical variable is any variable that puts subjects into individual independent groups. Ethnicity is a good one. Gender is a very common one. Political party, what type of psychological therapy a person is getting, that kind of thing, where it puts them in groups, and numbers really don't make a lot of sense, right? And that's a very common mistake, is we get people that will take an average of, let's say, ethnicity, and they'll come up with some number 2.7. And on an ethnicity scale, that makes absolutely no sense whatsoever. So with nominal variables, categorical variables, we never take means, we never take standard deviations. We don't use that parametric information, but we do use counts, right? Basically counts, maybe bar graphs to show the number, how many are in each group, that kind of thing. And the Likert scale you're going to use a lot if you're going to use a survey, which most of you will be. The Likert scale, again, it ranges from 1 to 5, 1 to 7, 1 to 9. Doesn't really matter how many far out you go. Where where the strength of whatever it is you're measuring increases as the numbers increase. So my favorite example is like military rank. A private would be a 1, a corporal would be a 2, a sergeant would be a 3, et cetera, right? The higher the number, the higher the rank. That's what a Likert scale is. And those are called ordinal, right? Because order is there. And they're also called rank variables or rank ordinal variables, or again, depends on the book and the teacher. Now, a good ordinal variable explanation would be like the top 3 runners in a marathon race. Who came in first, who came in second, who came in third. It doesn't illustrate the difference between the two. It just shows you the order of whoever is coming in first, second, and third. So that's the best way to think about a Likert scale. And then the variable types, right? Here's the big 3. You will be using a lot of continuous variables, I guarantee. You're going to be using a lot of nominal variables, I guarantee, right? Your nominal variables normally are a lot of your demographic variables, right? Ethnicity, gender, what program you're in. Continuous variables you're going to use like age, whatever you're measuring, depression, job satisfaction, whatever it is, where it's a continuous. The higher the number, the stronger the characteristic. And in ordinal, you will be using those as well. Basically, there's a lot here. I got the examples on the next page. Why am I talking about it? Okay, here's the one that I do not want you to use. Right? I even put the big red circle in there. Do not use interval data. Now, some teachers, they get it mixed up. They think interval data and ratio data are the same. Most of the books I read, they're not the same. So interval data, first of all, is not the same as a continuous variable. Interval data has no real zero. That's the definition that separates it from the other ones. In other words, the reason I do not use interval data, and I don't want anybody out there to use it, is because every book, and I've read about 15 different books, whenever they describe interval data, they all have the exact same example. And the example is this. It's about temperature. So in other words, the range in temperature between 10 degrees and 20 degrees is not necessarily the same between 70 degrees and 80 degrees. We can't say that. In other words, and another thing we can't say 40 degrees is half as cold as 80 degrees. That is not mathematically provable with interval data. And the last example is when it's 0 degrees outside, that just, to me, that means it's cold, right? But that does not mean that there's no degrees. Let me say that again. That's the thing that interval data does not have a real functioning 0. When it's 0 degrees outside, that does not mean that there's 0 degrees. Where with a continuous variable, how many purple dinosaurs are in your front yard? 0 means there's no purple dinosaurs. That makes sense, okay? So, but again, do not use interval data. And I'm kind of getting on my high horse here, but some books, they just go on and on and on about it, but don't use it. So some examples of continuous data. The easiest way to tell your variable is a continuous data is the range of the data, right? Your lowest number, your highest number is huge. You got a big range of data. So an example would be, depression scores. Some people are not very depressed, so they got very low depression scores. Other people are horribly depressed, so they have high scores. And depending, right? Let's say your depression score measurement tool, ruler, was between 0 and 100, right? You're going to have numbers all in between there. That, right off the bat, tells you you're dealing with a continuous variable, right? Age, weight, height, assessment scores, salary, just everything, is a continuous. Again, this will probably be your number one type of variable is a continuous variable. And then moving on, the nominal variable. And again, remember, nominal puts people in groups. So it's very important. If you have a grouping variable, you automatically open up opportunities for statistical analyses that look for differences between the groups. In other words, do men make more money annually than women? So if you have a grouping variable, that opens up all your t-tests and all your ANOVAs, because that's what it does. It looks for differences in different DBs, whatever you're measuring, between the independent groups. So again, any kind of grouping variable, gender, ethnicity, profession, type of therapy, car color, et cetera. Grouping variables. And then your ordinal data. I personally love the ordinal data. I love ordinal data because it's kind of like a cross between a continuous variable and a categorical variable. In fact, SPSS allows you to use an ordinal data as a continuous variable or as a nominal variable. SPSS does that for you. I always thought that was kind of cool. And you can tell it's an ordinal variable because you got levels, right? A good one is like, what does SES stand for? Social economic status, right? How much money a person makes. So you start at the low levels. The lower numbers mean not that much money coming in. The higher the number, the more money coming in. So it's that level thing. You can kind of feel it. You can kind of sense it. That makes it an ordinal variable. And a lot of them are simply three, right? Low, medium, and high. And I was working with some young lady today. She was doing it with depression, anxiety, and stress. And we broke down her continuous variable for each one of those. And she had the cutoffs from the literature review. And so we cloned those continuous variables into high, medium, and low because she wanted to look for differences. Okay? So that trigger word, differences, if you hear the word differences come out of your mouth, that means it's either going to be a t-test if it's two groups, more than two groups, it's an ANOVA, one of the ANOVA families. That means a grouping variable, which again, an ordinal variable can be a grouping variable. And if I start losing my voice, I'm going to cough or something. Again, Likert scales, you guys got to use them to death. Levels of SES, work position, right? Staff, management, executive, right? Staff would be one because they're the low man on the totem pole. Management would be in the middle. Executive, they're at the top. That kind of thing. When the number increases, so does the strength of the characteristic. Right? The larger the number, the stronger the characteristic. And please, oh, please, oh, please, oh, please, if you do make a survey, which most of you will, and you use the Likert scale, like how strongly do you agree with this statement? Or, how much does this statement sound like you? Always put the negative ones first. Start off with one is I do not like it, or one, it does not sound like me at all. And the higher the number, the stronger positive it is. So like 5 is I love it. 5, that you just described me to a T. The reason behind that is once you transfer that information into a bar chart or something, if you did put 1 as the highest, then the smaller the bar chart, the more stronger the characteristics. And that's upside down. That's counterintuitive. That screws everybody up. So again, with ordinal data, the negative ones start up the low numbers. The strongly positive ones are your high numbers. So why would you identify your variables in the first place? I'm about to tell you, because I said so. How's that? So Darcy spoiled. Thank you, Darcy. Because statistics literally only look, there's only 2 things in statistics you do, literally, period, stop, boom. Somebody should have told you this on the first day of statistics school. There's only 2 things. You're either looking for significant differences between group means, or you're looking at significant relationships between 2 or more variables. That's it, period, stop. Every statistical analysis on Earth is doing either looking for differences or it's looking for relationships. Differences. Again, differences need grouping variables. They need the categorical variables, the nominal variables. right? In other words, here's an example. Do men have significantly higher annual salaries than women? So your grouping variable is gender. Even though it's one variable, it has two levels. Say that again. Even though it's only a single categorical variable called gender, it has two levels, male and female, men and women, right? And the DV is what's physically measured from everybody, right? Both men and women. Whatever's physically measured in every group is your DV. So in this one, they're asking about how much money they make, right? And I think this has been proven a million times that yes, men do make significantly more money than women. And don't yell at me, I didn't do it. So I feel that people should get paid equally. And I'm, me more equally than others. So, okay, I just told you. The DV is the salaries and the levels of gender, the levels of the IV or gender. So all your difference type groups, all your different type analyses work just like this. There's got to be a grouping variable. Once you start identifying grouping variables, that's half the battle. Now, some of you guys have to pass comp exams, and I've been working with a couple of people. They have to do that decision tree practice, right? They throw a scenario out, and you're supposed to be able to come up with which analysis to run. So that's the first part. If you have a grouping variable in the question, more than likely, it's going to be a difference test, which means it's either a t-test or one of the ANOVAs. Okay. Right? Independent t-test. Or, if there's more than two levels, a level is a subgroup of a grouping variable. If there's more than two subgroups, like 3 or 4, like ethnicity, then you would use the one way between group ANOVA. Right? Here's an example. You're looking into difference. You're trying to see if there's a significant difference in anxiety scores between 3 different types of psychotherapies, right? CBT, ABD, and biofeedback, something like that, right? The trigger word is different. You hear that word difference coming out of your mouth? It's either going to be a t-test or it's going to be one of the ANOVAs. And this one would be a one-way between group ANOVA. Now, I don't want to go into the nomenclature here. That's kind of under a different subject. But one way means there's one categorical variable. And in this example, it's the 3 different types of psychotherapies. And the DV is their anxiety scores, right? That's a continuous variable. All one way between group ANOVAs need one categorical variable and one continuous variable. If you got that combination, then you're halfway there. Okay. Relations on the other side. We know what relations are. Everybody knows what relations are, right? There's a connection going on. There's, relationship, connection, link, cause and effect. I know we're not supposed to use cause and effect, but I use it all the time. Right? So a relation or relationship basically means this. When one variable changes, does that cause another variable to change too? Right? Or is one variable affecting another variable? Is one causing and one reacting? That's the relationship side. And an example is when the temperature goes up during the summer, does that increase ice cream sales? Yes, it does. And I want some ice cream now. Except for it's not that hot all of a sudden. Right, so you got the relationship between one variable, which is the temperature, and the other variable, which is the ice cream sales. Now, usually there's a cause and effect. Sometimes it's not clear, right? Maybe ice cream sales go up, the sun shines higher. Maybe the sun's working for the dairy product. Who knows, right? So sometimes it's backwards and you can't tell. Yes, that was a joke. Thank you again. All right. So those kind of relationships, see the word relation is directly in the name of the test, correlation. Co means two, and relation means relation. right? So if you're comparing two continuous variables, that's when you would use a correlation. The most popular one is we use the Pearson's correlations. Pearson's R, and they got to be continuous variables. There are several other types of correlations. There's a Spearman's correlation if your data is ordinal. There's a Kendall's if it's ordinal, it's a small sample size. There's a point by serial. You never want to use that. It just confuses the heck out of everybody. All right. So correlation is basically the same thing as a simple regression. So it's the same thing. It's a cause and effect. But with the simple regression, you get something what we call effect size R squared. And that's the percent of the variance of the dB that can be explained by your first variable. But again, that's something else. Multiple regression, that's where you have multiple predictor variables to try to predict one outcome variable. Example, does exercise, how many minutes a week a person exercises, how many calories a person intakes on a daily basis, how many fat grams, do they affect weight loss on a person? They all do, right? So that's what a multiple regression will do for you. And a multiple regression will tell you which one of your variables is significantly connected, related, predicting the DV and which ones are not. So that's a great test. I love that test. I love all these tests. I'm a weirdo, you guys. Okay. And the last one real quick. Oh my gosh, I'm running out of time. Is I never know where to put this one. It's about associations. This came out about 5 years ago. We used to call them relations. But all the new books say don't call them relations anymore, call them associations. So an association basically is looking for it's looking for a connection, a relation, an association between one level of a categorical variable and a different level from a different categorical variable. It's kind of hard to explain with words, but an example might do well. Here's a good one right here. This is an association test. Do men tend to belong to the Republican Party? Can you identify the variables there? I see two different variables, right? Do men. What about women? They don't mention women. So men and women, that's a variable. That's the first variable. It's called gender. It's got two levels, men and women. The second variable is political affiliation, right? They mentioned the Republican Party, but that's not the only political, right? You got your Democrats, you got your independents, you got your Green parties, you got your QAnons. Is it a Republican Party? Who cares? But that's two categorical variables, right? Gender and political affiliation. So do men tend to be in the Republican Party? I believe it is male heavy, right? So when you're comparing two and only two categorical variables, that's when you would use the dreaded chi-squared test of independence. Again, I tease because I really love these tests. So please, chi-squared test of independence, don't take that personally. And the reason you got to define your variables is because it'll make your life easier. I guarantee it. It'll make your professor's life easier. If you have to go through what you're thinking, oh, I misspelled variables. Oh my God, how embarrassing. These old. This is a drawing program, you guys. And I bought it way back in 1999. Yes, last millennium. This is Fireworks. Used to be part of Macromedia. Ask your grandparents about it. So, so again, if you know what your variables are before you meet with your chair and your board, they're going to love you. Okay, that's the number one problem. Is people bring their ideas and what they want to do, but they don't define what their variables are or how they're going to measure the data. Right? That's a biggie. How are you measuring your data? What kind of variable are you looking for? Do you want to put your subjects in categories, which is fine? Or do you want to use continuous variables? Again, that's fine, just as long as you know what you're doing. The clearer your variables are, the faster this stuff gets done. The tests themselves aren't that hard, right? I'm going to show you something here real quick. Where how every test in statistics that you need to know at this school, I guarantee I got 3 or 4 videos on how to do it by hand, how to do it in Excel, and how to do it in SPSS. Been doing this a long time. I'm kind of talking a lot here. But that's it. Da-da-da. The end.